How do I find midpoint? What's the midpoint formula? Absolutely. So that's midpoint. Oops, that should be a plus. I would definitely write that down. That is something to memorize. That is not going to be on your formula sheet. X plus X divided by 2 and Y plus Y divided by 2. What else do we need to know from either unit 1 or unit 2? What's converse? Yeah, QP. We changed the order. What's inverse? Not P, not Q. You insert that not, right? Yeah. That is X plus X. Let me make that more clear. That is X plus X. I don't know that that's really any more clear, but that is what it is. Okay. What else do we need to know? Distance. What is the distance formula? It is. Do you remember the circle formula? Is X minus H squared. Distance formula is X minus X, and then plus, and then Y minus Y all squared. The distance formula and the circle formula are almost identical. You just have an X and a Y instead of an H and a K. What else do I need to know? Ooh, I forgot slope over here. What's the slope formula? How do I find slope? Rise over run. How do I rise? On the X's or the Y's? So we need to do rise over run. Y minus Y over X minus X. Okay. Which things are valid and which things are invalid? So I've got valid and invalid over here. I'll have valid and invalid. Which patterns are valid and which patterns are not valid? Is PQ valid? PQ is valid. So the regular way, the way we always write, the way it always starts is PQ. And then if I turn it backwards and opposite, that's also valid. So not Q, not P is valid. These two are the only valid things, okay? So this is P to Q and not Q to not P. Those are valid, okay? When you're doing these valid and not valid, don't actually read the words for meaning, read them for patterns. Then the not valids, there are only two. Yep, Q to P, not Q to not P. So the contrapositive is valid and the conditional is valid. The converse and the inverse are not valid. So when I change the order, that conclusion is not a valid conclusion. And if I just insert the not, that is also not a valid conclusion. Okay. Feel like we're all good on our symbols. This is really the sticking point. If you're going to miss a logic question, my guess is it's going to be this one. Okay. So make sure you have all of that. Valid is P to Q or the contrapositive, not Q to not P, but invalid are the converse and the inverse. Read for patterns, not read for meaning, okay? Then we've got midpoint, distance, and slope. What about if I ask you the other end point? What do I do for that? You do the chart. And what has to go in the middle? Seems crazy to have to say that, but the midpoint goes in the middle, right? So the midpoints go here and the endpoints go on the end. Just kind of makes sense. All of these things are just memorizing things. So if you're just coming in, we're making a little cheat sheet. You should have a piece of paper out and you need to write down all of these things. You're going to be able to use them on your practice SOL and on your circles test today. Okay. So let's. The circle. So the circle formula is up there. If you compare it, it looks almost identical to the distance formula. So instead of x minus h squared, you've got x minus x squared. And instead of y minus k squared, you've got y minus y squared. Okay. Let's go look at Unit 3 and Unit 4. What do I need to know from Unit 3 and Unit 4? It's the important stuff. Lily. Yeah, how do I know the difference with slopes between perpendicular and parallel? Absolutely. So we've got the same slope for parallel, and then the opposite reciprocal. So if I have 1 over 2, the perpendicular slope is negative 2 over 1. We're going to do the opposite reciprocal for perpendicular. Okay. Do we know all our angle pairs? Which ones are congruent and which ones are supplementary? Adjacent angles. They're next to each other. They don't have like a number relationship. Vertical angles, are they congruent or supplementary? Congruent. How about linear pairs? Supplementary. How about corresponding? Congruent. Alternate interior and alternate exterior? Congruent. And what about same side? Same side is supplementary. Okay. That was a lot of me talking and not a lot of me writing, so I'll give you a minute. Make sure you have these as a visual in your head. There's up above Casey's head kind of a colored picture of all those angle pairs. The same side supplementary and the linear pairs are the only ones that are supplementary. All the other ones are congruent. You can also remember acute plus obtuse equals 180. So if you can visually see, because some people can't, if you can visually see that you have one smaller than 90 and one bigger than 90, they're always going to add up to 180. Well, 9 times out of 10. If you've got the exact same size angle, acute equals acute, and obtuse equals obtuse. Okay. We're really good at the parallel line stuff. Yeah. If they're a linear pair, yes. So if I just have adjacent angles that look like this, like I've got a diagonal and some kind of quadrilateral, those aren't going to equal 180. They're not necessarily going to equal each other either unless it's bisected. So kind of the adjacent just means neighbors. That's a great question. Alternate is the Z. So the alternate is when you can make a Z with the parallel lines and they're congruent. Absolutely. It's a lot of information. You've learned so much this year. What about triangle basics? That was the boot camp from yesterday. What's triangle sum mean? Lily? Yeah, triangle angle. So if you add up all the angles, what do they always equal in a triangle? 180. So when I say triangle sum, that's what I mean. What about triangle inequality, that Hinge theorem? What do we have to do there? We've been practicing that all week. So I subtract the two numbers, and then I add the two numbers, and I want everything in the middle. So if you have two numbers and you're looking for the range of that third side, you want to subtract and add. What question does this formula answer? Small plus medium is bigger than large. Is it a triangle? Absolutely. Is it a triangle? Is it a triangle? I know it's hard to see. So, Ray, will you turn off one of those light switches? It doesn't matter which one. Does that make it easier to see? Samuel, you want to pull that down? That might help. We can do that one too. There we go. What does this mean? Small is opposite small, medium is opposite medium, and large is opposite large. That's how I order those sides and angles, right? So small is opposite small, small side is opposite small angle, medium side is opposite medium angle, and large side is opposite large angle. Okay. Exterior angle equals inside angle plus inside angle. Ah, I know what I meant by that. I was like, what the heck is that? That's the exterior angle theorem. So this exterior angle is the sum of this interior angle and this interior angle. I should make 3 loops here because all 3 of those things can be different. So the exterior angle of a triangle is equal to the sum of the 2 interior angles that are not adjacent to it. So the exterior angle is congruent to the interior angles that are not adjacent to it. Exterior equals interior plus interior. Outside equals inside plus inside. Exterior equals inside plus inside. Okay? Hopefully everybody's writing this down. So it would be like if this was 100 and this was 55, and I'm looking for this one, I would do 100 equals 55 plus x, or 100 minus 55 equals x, and x equals 45. That would be an example of that. But sometimes they give you expressions. Does that make sense? With congruent and similar, you just need to memorize these. So write all these down. There's 5 ways to prove congruent. Side, 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 angle, 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 side, and hypotenuse leg. Congruent means they're all exactly equal. They have to be the exact same size down to the last decimal. Okay. If I see this similar symbol, what automatically do I need to think in my head? Proportion. Those sides have to make a proportion, but the angles are going to be equal. Okay. The sides are proportional, but the angles are equal. You guys got to let me know if I'm going too fast or too slow or whatever. For congruent or for similar? This one is similar. Yeah, this one is similar. So similar looks like negate, and congruent is the equal sign with the squiggle on the top. All the symbols in geometry can be really crazy. And I don't know why Google puts that little dot on top. I have no idea. Then we've got right triangles. Right triangles, if you know 2 sides and you want to find a side, you use Pythagorean Theorem. What is the Pythagorean Theorem? A squared plus b squared equals c squared. That is on your formula sheet. I'm going to show you that in a minute. Then we've got trig. We use regular trig to find a side if you have an angle. So for trig, you need to either have an angle or want an angle. Remember, the second letter goes to the numerator and the third letter goes to the denominator. H's always go in the denominator, O's always go in the numerators, and then A's fill in the gaps. Okay. Inverse trig, what's the symbol for inverse trig? What do we have to remember to put in there? Instead of the angle, you put the little -1. So inverse trig has a little -1, right? And here we're finding angles. Okay. I hope all of you feel accomplished, that you've learned all of this and are remembering all of it. It's a lot. It's a lot. After we make our cheat sheet, I'm going to show you the formula sheet, and you're going to see why we made this. So hopefully everybody's writing it down. All right. Unit 8. Oh, so many formulas. Just write all of these down. Interior plus exterior equals 180. The total interior, make sure you look for that total, or maybe the word sum, S-U-M, not S-O-M-E, is n minus 2 times 180. Then if it says each, you've got to divide that total by n. Remember, n is the number of sides. No, the struggle is real. What is this pencil thing in my hand? I don't know. Remember, the total of all the exterior angles of any polygon, anything with sides and corners and no circles, is going to be 360. Make sure you read that word total. That is a minus sign. So you take the total of the interior angles and then divide it by n. So your formula might look like n minus 2 times 180 divided by n. That's going to find each interior angle. And that is definitely a subtraction sign. Thanks for asking for the clarification. Then we've got the total exterior angles is always 360. So to find each exterior angle, you can just divide by the number of sides. Okay. We had 1, 2, 3, 4, 5, 6 formulas for this one unit, and that was just for polygons. I didn't even put anything down for quadrilaterals here. And then number of sides divided by 360 equals the exterior angle. So 360 divided by, oops, that should be a 6, divided by n equals the exterior angle. That's not very clear. 360 divided by n equals the exterior angle. 360 divided by n equals the exterior angle. For quadrilaterals, I would encourage you to draw those pictures on graph paper whenever you have a question with them. So if you have a rectangle question, draw a rectangle on the graph paper you're given, and then see what you can see visually. You guys came up with all kinds of great insights into the shapes before we even learned anything about them, because you know all your quadrilaterals. It's just a matter of these questions are super nitpicky. So draw yourself a good shape on graph paper so it's nice and congruent and symmetrical, and then just look at your picture. You're really good at that. Then we've got all our circle formulas that we've brain dumped a couple of different times. The circle equation has a center and a radius, right? The circle equation is x minus h squared plus y minus k squared equals r squared. Remember, the end of the equation is always squared. And the equation and the circle have opposite signs, or the equation and the center have opposite signs. Okay. I know it's a lot. Your hands are probably getting tired. We've got arcs and segments. That weird circle with the line through it is just the theta. So that's the angle divided by 360. And then times either the circumference or the area, right? Yeah.
The number of sides, 360 divided by exterior. What is 360 over n equal?
The exterior angle.
Okay.
Central angles are congruent. Inscribed angles are half. So if you go from the angle to the arc, you multiply by 2. If you go from the arc to the angle, you divide by 2. If it's central, the arc and the angle are just equal. That's what these two things mean. Remember, chords are inside the circle. So if you have an X somewhere inside the circle, you've got 4 segments. You multiply the 2 that make one line and the 2 that make another line, and then you set them equal. There should be an equal sign in there. So AB equals CD. Make sure you put that equal sign in there. I don't know what I was thinking. In fact, I wonder if I can put an equal sign in there. Okay. And then we know outside times the total and outside times the total, right? This is what your test is on today. Again, if you're in the room, all the formulas are up around the room. If you're at home, hopefully you brain dumped these the other day and you have them all, or you have them now. You can also look in the Circles notebook, okay? When you're going through your test today, if you have a question and you're not sure what to use, look in your Circles notebook. Any questions on 8 and 9? Do I need to give you another minute?
Yeah, I need a little bit of time.
Okay. I'll give you a little bit of time. Okay. Okay. Let's look at that. And I'll open it back up because it closed last night, didn't it?
Yeah, I was working on it at the booth.
Gotcha. Let me open that up right now while we're letting everybody write. Secants. Mm-hmm. Secant, seek, and tangents touch. As long as you remember to do the outside twice. Yes. All right. We ready for the last slide? Okay. So the chords look like X's. Everything's inside the circle. Secants and tangents, you've got an outside piece. Or maybe just one outside piece. But it's the outside times the total equals the outside times the total. It's easier to see up there by Lily and Quinn's head.
It says sign beside the R.
Besides R, oh, right here? Yes. So that's like the ice cream cone. The ones that look like that. That piece of the cone and that piece of the cone are both congruent. That's what that's saying. You do have access to this whole slide deck, so it is in today's folder. So if you didn't write everything that's in black, that's there for you. My writing is not going to be on there, but I can try to post this video. Okay. Let's look at the last slide. Surface area and volume, and then transformations. So surface area and volume we're going to talk about next week on Wednesday. But there is one thing that I want you to write down. Write down this chart. Okay. So linear area and volume. And then this dm means dimension. So whatever your number is, for linear things, radius, circumference, diameter, you have a power of 1. For area, you have a power of 2. Everything area is squared. And then for volume, you have a power of 3. It's a dm for dimension. And then we're going to do one little example. If I have a little cube, like one little piece of a Rubik's Cube, it's 1 by 1 by 1, right? So my linear dimension is 1. My area is 1 times 1, which is also 1, right? The area of the top is just 1 times 1, which is still 1. What's the volume? That's going to be 1 times 1 times 1, which is still 1, right? So this is 1 centimeter in length are all of the sides. 1 centimeter squared is all the faces, and then 1 centimeter cubed is the area of the whole thing. It's just one little brick. Do you have a Rubik's Cube? I do. Okay, so I'm just talking about one of these little bricks, right? One of the little bricks in a Rubik's Cube. How big is a whole Rubik's Cube? What's the dimension, like the linear dimension on a Rubik's Cube? How tall is it? It's 3. So if I have a whole Rubik's Cube that's 3 by 3, my sad little Rubik's Cube up here, the linear dimension is 3 centimeters, right? What's the area of one of the faces? How many squares are there on each face? 6? 9. And then what's the volume? 3 times 3 times 3. How many little cubes make up this bigger Rubik's Cube? 9 times 3. 3 times 3 times 3. Length times width times height. So that's 27. Is that correct? So hopefully you have exactly what I have, but a little neater. Linear area volume, dimension to the first power, dimension to the second power, dimension to the third power. If I have one little cube, that's 1 by 1 by 1. If I have 3 cubes, that's 3 by 9 by 27. Look at the relationship here, though. What is 3 squared? 3 squared is 9. 3 times 3 is 9. And what is 3 cubed? 27. When you have similar figures, you can use this chart to go squared and cubed and predict the next thing. It's going to make more sense to you in a couple of days, but I want you to write it down now. Okay, so even if this doesn't make any sense, please write it down. Linear area volume, dimension 1, dimension 2, dimension 3, 1 centimeter, 1 centimeter, 1 centimeter, centimeters linear, centimeters squared, centimeters cubed, and then centimeters. I made it 3 times as big. That makes it 9 centimeters squared and 27 centimeters cubed. All I did was take that linear dimension and square it and cube it. Okay, this is going to help us in a little while. And then our last, maybe most favorite, maybe least favorite unit was transformations. These are the last part of our notes. So if your hand is tired, your brain is tired, you want to give up and stop writing, please commit to just writing these last 4 things. Okay, these are your little cheat sheet to remind yourself how to translate, reflect, rotate, and dilate. When x adds to it, you move right. When x subtracts, you move left. When y adds, you move up, and y subtracts, you move down. If I'm reflecting over the x-axis is horizontal, right? So whatever the y is, I change the sign. If you're flipping over the x-axis, you change the sign of the y and keep the x. If you're flipping over the y-axis, you're flipping right to left. So you keep the y and you change the x. If you flip over the y-axis, you're flipping right to left, so you change the x. If you're flipping over the x-axis, you keep the x and you change the y. Now, if you're flipping diagonally, that's a whole different story. X equals y, then y equals x. You just switch these two things. So if you're reflecting over y equals x, you just switch those two things. Okay. And this should say, actually, let me change this. This should say switch x and y. So when you rotate, you're going to predict where you land, predict the quadrant, and then switch the x and the y every 90 degrees. So every time you turn into a new quadrant, you switch the x and the y, and then you just match the signs based on where you ended up. Okay, these are the hardest ones to remember. Each 90 degrees. So when you're rotating, if you rotate 90 degrees, you switch the x and the y one time. If you rotate 180 degrees, you switch the x and the y, and then you switch them back. If you go 270, that's 3 quadrants, so you switch back, and then switch again. And then for your signs, you just put, like if it's in quadrant 1, it's positive, positive. If in quadrant 3, it's negative, negative. 2 and 4, one's negative, one's positive. Scale factor, you always multiply. Okay, always multiply with scale factor. My hope is these notes will help you as you go through the circles test and the practice SOL today, the district benchmark, okay? I'm going to open 2 tests for you. I'm going to show you where they are now. If you go into like our main page, the district post-assessment is right here. This is essentially the final exam if you're a sophomore. And if you're a freshman, this is your last practice SOL before you take the SOL on Friday the 4th. Okay, that's still 2 weeks away. The formula sheet is directly underneath it. So if you click on that link, you will see the formula sheet. Notice that it's 2 pages. Please, please, please use it, okay? The whole first page is all of these 3D shapes that we haven't even talked about yet. But you're really good at algebra, so I feel like the pictures lead you to know what you're supposed to do. We'll talk about these next week, don't worry. The second page is, I think, the most useful page. It's got Pythagorean Theorem with a nice picture, and it's got sine, cosine, and tangent with a nice picture. Okay, so sine of theta, sine of your angle, cosine of your angle, tangent of your angle, and it gives you what you need for the ratios. It shows you a picture of the O, the A, and the H. And then there's also the circle formula. HK is your circle center, R is your radius, and then you've got your circle formula here. Okay, you won't need the quadratic formula. I don't even know why they put it on here. I've never seen a quadratic formula question. Quadratic formula? Oh yeah, next year you'll use it a lot. No, you won't. You also have a bunch of symbols down here. So if you're ever trying to translate a question and you're not sure what the question says, look at your symbols, okay? It gives you all kinds of letters over here. Little p is the perimeter, big B is the base, LA is the lateral area, SA is the surface area. And then we've got measure of angle A, we've got raised, we've got parallel, perpendicular, congruent, and similar. Okay, all kinds of good stuff there. I did have 1 or 2 questions on the homework from like that 17 question homework from whenever we were doing that. So if you want to open up that homework, I just re-released it. So you are welcome to do that with us. If you don't have any questions on the homework, the test should open up in like 30 seconds. What questions do we have on this homework that we can talk about before we start the test?
What is the answer to the first
On 1 through 10? That's going to be a big fat question mark. The questions? The answer? I don't know, babe. You're going to have to figure that out. It's a good question, though. Nice try. Yeah. What do we need to talk about in the 17 question homework? Oh no, is Schoology being crazy? That was a right triangle. Do we need to talk about that one? No? Okay. 12, 13, 14, 15, 16. Was it this one? This is the 17 question one from exterior angles. Okay. So with these questions, and you will have some of these on your homeworks or on your test, so I'm glad we're talking about them. If you have a circle equation and you need to graph it, put it into Desmos. Okay? So step number 1 is just going to type in exactly what you see. So for this one, I'm going to do x minus 5 squared plus y plus 1 squared equals 16. And somehow I missed the square up here. Once you get your visual, then look at your question. What is the center and radius of the circle? Oh, so the center is going to be halfway across. 1, 2, 3, 4. It should be right there. So that's 5, -1 maybe? 5, -1. And if I go back, that makes sense because my 5 in my equation is negative, so my 5 has to be positive. My 1 is positive, so it has to be negative, and then you can just count 1, 2, 3, 4. So this is one of the easier ones to do. If we go up to 13, it's a little bit harder because here we have 4 equations, right? But if you take the time to type in all 4 of these equations, you'll see that only one of them has a center at 2, -1 and goes through -1, 3. So I would just go back to this equation and substitute everything. Question 12 is the hardest of the 3, okay? But you're going to do it the exact same way. You have all your answer choices. So put in x plus 1 squared and y minus 4 squared equals 9. And then put in these points, -4, 4. On the test, yes, please use Desmos. -4, 4, and 2, 4. So when you get questions like this where it says these are the endpoints of the diameter, which equation matches it, put in your 2 endpoints into Desmos, put in all of your equations and see which one matches. Does that make sense? And once you get your first equation in, if it's not the first answer choice, you just change the stuff. You don't have to retype it a bunch of times. Okay? You're welcome. Any other questions on the homework? We feeling good? Okay. All right, then let's go to the test and see how we do. So just to be clear, your 2 assignments between now and Tuesday are the circles test and that district test. The circles test is in today's folder and the district test is at the top. Both are graded. What? Welcome. As always, let me know if you have questions, okay? And if you're at home and you want to go and just do this on your own, you're welcome to do that. Come on back if you have questions, or you can just stay and hang out. Sadly, you cannot. That is not an option for you.
If I,
Mm-hmm.
on question 3, over that.
Mm-hmm. Mm-hmm.
My question is, to set it up, we have to use this one, though.
Mm-hmm.
Which would be pi a squared, but
Mm-hmm.
my question is, if there's 6 equal pieces, what would we do with that?
If you are physically cutting a pizza into 6 equal pieces, what are you doing mathematically? Adding, subtracting, multiplying, or dividing? Mm-hmm. Don't overthink it. Mm-hmm.
That's all we have to do is this.
Mhm.
How do you do number 4?
Number 4 is the easiest complicated question we did yesterday. Mm-hmm. Mm-hmm. So ask yourself, what equation relates circumference and diameter? What equation relates circumference and diameter? It's the easiest complicated question you will ever see. Mm-hmm. Set them equal. Mm-hmm. I wrote it, Sarai. Mm-hmm. You can absolutely use the notes that you just took and your formula sheet and your digital notebook. Use all the resources. That's a good question. Let me see. The shortest way. So if I'm going from J to F, I'm going to go the shortest way around the circle. That's a great question.
And then for phi, I know you have to take pi out of the equation when you solve it.
Mm-hmm.
But when you put the 120 over 360.
Mm-hmm. Mm-hmm. There's a simpler way to do it. Mm-hmm. Look at the equation above you. Look at the equation above that I wrote in blue. How's mine different than yours? Are you looking for area or circumference? Okay. Mm-hmm. What's the equation, or what's the question give you in number 5? Uh-huh. Mm-hmm. Gianluca, which question are you looking at? Those are both secants, yeah. Are you looking for angles or are you looking for segments though? So that's day 5. Everybody should have that test open.
So, after I do the big minus small, I get the number I divided by 2. I guess I still get some because it's not me. Unless they're wrong.
The correct answer is there.
Wait, you got one,
Mm-hmm.
right? Are you supposed to do something after you get that number? After you divide it by 2, is that going to be
That's going to be your answer. Make sure you do big minus small, enter in your calculator, and then divide by 2. Otherwise, the order of operations go a little crazy. Yeah. Okay. Are you looking for segments or angles? You do. You got to find this one. How many degrees all the way around the circle? So there's 1 piece, 2 piece, 3 piece, and 4 piece. So you know 3 of the 4 pieces, and you're looking for this piece.
Oh, that's what we're supposed to do. I was doing that for thinking.
So think of the angle like your mom or your girlfriend or your boyfriend, somebody who's trying to give you a hug, right? The big arc and the little arc are both inside the hug, inside the angle. So everything big minus small and the angle are inside of that angle. Big minus small divided by 2, but you got to know what the small is.
Oh, 96 isn't small.
96 is not the small.
That one.
It's outside the circle. I could care less about the 96. Yeah.
The small bit is that's going to be accent, right?
This angle right here, or this arc right here. There's 3 things inside this angle. The angle itself, the small arc, and the big arc. Big minus small divided by 2. Big minus small divided by 2.
Or you could just do 360 minus 5.
Which question? You have equals 10? Oh, no. So you should be able to find it. Even if you don't, what's the pattern here? That positive, take that negative. I think that is the way it is. Did you have that? And if you type the second in, it should work out. Yeah, because you need to take the square root of that, because that's like r squared. And the equation and the circle center have opposite signs. And -7 is +7 and -2 is +2. Was that intentional or was that just the default? Like, I just chose A. Well, that is why. So if you look at your like equation in the circle, remember that the H and the K are backward signs. So if you see a minus, it's got to be positive. And if you see a positive, it's got to be minus. But type it back in and then verify that that's correct. Morgan?
For number 7, don't you have to find the small angle and then do the formula?
The small arc?
Oh.
9, come back over here. I think you're missing a parenthesis. There we go. And then come back in here and can you make that quicker? So you get closer. Yeah. Why isn't that proper reflection? Oh, because that's a Y. Because that should be a Y. Now I understand the problem. Because that is a typo. That should be a Y. Let me email them about that because I can't change that. But thank you. This is 13?
Yeah.
Thanks, Jada. In number 13, this second part of the formula right here, that should be a Y. So this one right here, I'm trying to highlight it color, you can actually see that X should really be a Y in question number 13. Logan, you can go. You're welcome.
Question 10.
Mm-hmm.
Can I be a point off or no?
Like a decimal point off, like a rounding thing?
Not like around it, but it's actually like 1 point off.
It should be exact. Mm-hmm.
Because I'm point off.
Check to see that you typed everything in right, because I think it's exact. Mental math is great, just verified in the calculator. I know some college professors won't even let you use a calculator. Somebody's got to program that robot. Calculators are only as good as their programmers. Lily? That's the outside times the total equals the outside times the total. Make A be X.
Wait, we have another test after this?
The one that's due on Tuesday.
Oh, we're not doing that one? That's not all.
You're welcome to do them in whichever order you want.
Or that's just these two tests are just options you like.
Skipping all the logic questions. It's not even that bad at logic.
Is that one like end of the year question system? That one, whatever we get out is the grade we get.
Yes.
Okay.
That goes in the regular.
It'll be curved, just like the other practice SOL though.
I would be correct. You suck. Not comparing. Not comparing.
For all
I know, but I thought that closest to the part.
Because I get to choose. Because I'm the queen of this room.
of them.
The homework is that district assessment. So if you go out to the like main part of the course, it's at the very top. It says T&L Geometry Division Post Assessment.